Okay, let's take a look at the three labs that you're being assigned this week in Math 136 in GeoGebra. Now, one thing I want to say right off the bat is that these labs are fall into the content of the next sections. So just because of the timing in the course, we have a lab today that's actually not due until May 1st, so some 3 weeks from today. And so the content in the lab is actually on chapter 14, which we haven't covered yet. So it'll be a nice preview to chapter 14. And just keep that in mind as you move through the lab today. So one of the things I'm going to ask you to construct is an area of a triangle explorer. So the idea here is that I have a point D that moves along a line that's parallel to the base of the line that contains the base of the triangle. And one of the curiosities of this particular construction is that no matter where I move that point D, the area of the triangle remains the same. Looks like it's 15 here. So moving that point D along that parallel line for some reason doesn't change the area of the triangle. Now if I change the size of the base, the area of the triangle does change, but still it looks like the area remains constant no matter where I put D along this parallel line. If I change, I guess, the height here of the triangle, then of course the area does change again, but again, moving D along that parallel line doesn't change anything. So 5A is this type of a construction. Let's go ahead and talk about how to construct the figure really quick. So I'll just Control Alt and Delete. So to construct the figure, the first thing we're going to have to do is construct a line, AB, and A and B will be the base of the triangle. I'll put a point up above the point, that'll be point C, and what I want through C is a parallel line to AB. So to do that, we come over here to the parallel line tool, and we select a line and a point for it to go through. So there we have a parallel line, meaning anytime I move A and B, the line that contains C that's parallel to AB will move accordingly. I'm going to put a point on that line D and go ahead and construct the triangle. Oops. I'm going to go ahead and do that again. I missed it. Put a point D on that line and then go ahead to my polygon tool and construct the triangle I need. Okay. So from there I can get the point D to move along that line as needed. To find the area of D, there's the measurement drop down will give us the area, so I'll measure the area of the triangle DAB. And then the last thing you're asked to do is to create a segment here that we would think of as the altitude of the triangle. To do that, you need to construct a perpendicular line to line AB that passes through D. So how do I construct a perpendicular? Again, under this drop down, we can find perpendicular line, choose the segment you want to be perpendicular to and the point you want to pass through, and there you have a perpendicular line. What that does for us is define an intersection. So that's the intersection point of the lines that are perpendicular. I can now go ahead and hide this big line and put in a segment there instead of a full line, just to make the drawing a little easier to understand. And then the last thing I ask you to do is to make the lines that are sort of, I guess, describing the figure dotted. So I'll just format this one to be using object properties and style to be a dotted line. And I'll format this one as well using object properties and a dotted line. So in a nutshell, that's what I'm asking you to do in Lab 5A to create this figure. It is kind of fun if you right-click this and go to Object Properties, and if you right-click point D and just turn animation on, you can of course make it play itself if you'd like. And you can see that even though the triangle is very, very wide out there, the area of the triangle remains constant at 27, at least for this particular configuration. So in a nutshell, that's Lab 5A. Let's see, so Lab 5B is very similar to Lab 5A, the only difference being that instead of constructing a triangle, you are going to construct a parallelogram between two parallel lines. And a similar property seems to emerge that no matter I guess, how sheared the parallelogram is. As long as the base distance remains the same and the altitude of the parallelogram remains the same, then the area remains constant. So here 48 square units, no matter how I shear that particular parallelogram. So I think I will just, since the construction is very similar to that for the triangle, I'll let you go ahead and attempt that one on your own without any direct instruction. The last one is significantly different, and it's a Pythagorean theorem explorer. So what I want you to do here is simply to build a triangle and then construct a square on each leg of the triangle. So you can see that I have a triangle constructed and that there's a square on each leg, and that it's dynamic, that if I move this up here, then I know that these areas are going to change, but I guess what we're trying to allow for discovery is that the area of the red triangle plus the blue triangle will be the area of the green triangle, the famed Pythagorean theorem, which states that a squared plus b squared equals c squared. So it's a visual display or explorer of the Pythagorean theorem. Let's talk about how to construct it. I'll go ahead and Control Alt and delete everything, and we'll go through the construction sequence just briefly. So the first thing you're going to need, obviously, is some sort of a triangle, and you might as well make it a right triangle. So using the grid and snapped, I'll let it be a right triangle. There it is. So the next thing I want to do is construct a square on this leg, on this leg, and on this leg of the triangle. So I'll start by constructing the square on this leg. And it's fairly easily done because there is a regular polygon tool in GeoGebra. So if you choose the regular polygon tool, it says select 2 points and enter the number of vertices. So I'm going to select this point and enter 4. And it constructed a square, but of course it constructed it on the wrong side. So I mentioned this in the instructions. This is a directional tool. I'm going to go ahead and edit undo and try it in the other direction. Notice that I selected this point first and that point second, and it put it on the wrong side. So I'll select this point first and that point second with 4 vertices, and now I get the triangle on the right side. So I simply just have to repeat that 3 times to get 3 squares built on the original triangle. Now they're off the screen, so I'll make it a little bit smaller so we can actually see this thing. So there we go. We have a square constructed on all 3 sides of the triangle. At this point, what I ask you to do is perhaps use some color to make things a little bit more interesting. So there's a blue color there for that polygon. Why don't we do, I don't know, a green color for the other one, and why don't we do a, I don't know, red color for that one. And then what about the one in the middle? Let's just do that one as black. I guess I'm going to select all the polygons and make the opacity a little bit thicker or easier to see. Well, that's pretty nice. And the last thing I want to do is I want to measure the area of each of the polygons. There's a number of ways you can do this, but the area works just fine here. So I'll hit area here, and area here, and I can see that 9 and 16 and 25. That's one way to do it. I think I'll take those away. Another way you can do it is to insert text, if you like. Here we could let this be, say, a squared, symbols square, and let that be equal to, and then the thing that I want it to be equal to is polygon, let's see, 2, I guess. So I'll come down here for polygon 2 and 16, okay. So that's one way you could do it as well, and repeat that procedure for these 2. So I'll do that as well. In fact, what I'll do is, so b squared equals, and objects, let's see, not polygon 2s. We want polygon 3. Okay, so there's the, this would be that one, this one would be that one, and then the last one we would do would be c squared equals, and that would be polygon 4. So kind of a nice dynamic explorer. I can see now that 9 plus 36 is indeed 45. Um, if I make it smaller, I can see that 9 plus 4 is indeed 13, and it's a visual explorer of the Pythagorean theorem. Okay, well, good luck with your lab this week, and I look forward to your submissions, and please let me know if you have any questions.